Today we're going to be looking at solving multi-step equations. This is a picture that I took while I was at the ruins of Pompeii, and it just amazed me that they had the design sense and the know-how to make this tile floor. If you zoom in on it, it's just itty-bitty little, probably centimeter by centimeter tiles that they placed in this intricate design. And because it was covered by ash, it was preserved for hundreds and hundreds of years. So I just thought it was really pretty amazing. When we're looking at solving equations, you want to think of doing your order of operations backwards, or Sally Aunt, dear my excuse please, or SADMEP. Our first step when we're solving our multi-step equations is to collect all the variables on one side of the equation. We're not going to be dealing with this so much today, but we will start dealing with it with our next section of notes. Step 2, combine all your like terms. Remember, like terms have the same variable with the same exponent. Step 3, undo any addition and subtraction, just like you did with your two-step equations. Step 4, undo any multiplication and division that's occurring. With all of these, remember your goal is to isolate your variable, or to get your variable by itself. Example 1, we've got 9x plus x minus 7 equals 13. So the first thing I'm going to do, I'm going to draw a line through my equal sign to make sure I'm doing the exact same thing on both sides. Now I've got 9x and I've got an x. Those are like terms. They have the same variable to the same exponent. This x by itself is like a 1x. We just got a little bit lazy about writing the 1 in front of it, but it still means the same thing. So my first step, I'm going to combine those like terms. 9x plus another x gives us 10x. So I have 10x minus 7 equals our 13. From here, I need to undo any addition and subtraction. Well, the inverse, or the opposite of subtracting 7, is going to be adding 7. And we need to do this on both sides of our equation. Negative 7 plus 7 cancels, so I'm simply left with 10x equals a positive 20. My last step in this situation, I have to get rid of the multiplication by 10. The inverse of multiplying by 10 is going to be dividing both sides by 10. Which leaves us with x equaling 2. Now, I'm not going to require you at this point to substitute this value back in, but I highly, highly recommend it. So if we do substitute it back in, that's 9 times 2 plus 2 minus 7. And if we've done this correctly, that should equal 13. So let's see, 9 times 2 is 18 plus 2 minus 7. 18 plus 2 is 20, and 20 minus 7 is in fact 13. So we have our equation equaling 13 on both sides. So that means we've done this problem correctly. Your turn. Pause your video and try this problem on your own. Did you get y equals negative 6? If you did, give yourself a hollowed out centered star. For our next example, we've got 40 equals 5 times the difference of d and negative 2. We've got a couple different ways that we can solve this problem. The first way is to distribute the 5. By doing that, we'll end up with 40 equaling 5 times d is 5d, 5 times negative 2 is negative 10. So 40 equals 5d minus 10. From here, we can then add 10 to each side.
just like we do in our other two-step problems. 40 plus 10 is 50. So 50 equals 5D. To undo multiplication by 5, we're going to divide both sides by 5. Dividing both sides by 5, we are left with D equaling a positive 10. Another way we can approach this same problem is to, instead of distributing the 5, we can get rid of it. So to get rid of it, let's see, 5 is multiplying with the parentheses. The inverse or the opposite of multiplying by 5 is dividing. So we can divide both sides by 5 first. Multiplying the parentheses by 5 and dividing the parentheses by 5, those cancel each other out. So I'm just left with D minus 2 on the right. On the left, 40 divided by 5 yields 8. Now we just have a one-step equation. To get rid of subtracting 2, we need to add 2 to each side. 8 plus 2 is 10, so again, we still get the same answer of D equaling 10. The method on the right is just a little bit shorter and easier to follow. On our next example, we're going to see why this second method is even more important.
Our last example for today, we're going to throw a fraction into the mix. We've got 3/5 times the difference of 2x and 4 equals 18. Now we have a couple different ways to solve this. The first thing we could do is go ahead and distribute our 3/5 x. I'm sorry, our 3/5 to each part of our parentheses.
This is exactly what we did for the first step in our last problem. Here you can see it's going to be even more complex than the last one.
So let's see, 3 times 2, that's 6, so that's 6/5 x minus 3 times 4 is 12, 12/5 equals 18. We can either leave those in fraction form or we can go ahead and put them in decimal form. I'm going to go ahead and put them in decimal form just because it makes it a little easier typing wise. So let's see, 5 goes into 6 once with 1 left over, or 1/5, which is 2/10, so 1.2x minus 5 goes into 12 twice with 2 left over, so 2 and 4/10 equals 18. Add 2 and 4/10 to each side. Those values cancel. And we're left with 1 and 2/10 x equaling 18 and 2 and 4/10 is 20 and 4/10. Divide both sides by 1 and 2/10. And we get an x value of 17. Not impossible, but definitely not the easiest way that we can work through this problem. Our second option is much, much nicer in my opinion. For our second option, what we can do, we can get rid of that 3/5 x from the start. 3/5 is being multiplied by our parentheses. The inverse of multiplication is division. So we can divide both sides by 3/5. Whenever we divide fractions, you can do your leave, change, flip. So we can flip that 3/5 into 5/3 and multiply both sides by 5/3. Now, life's going to be much easier. 5/3 times 3/5, well, that's just 1. So I'm just left with 2x minus 4 on the left. On the right, we have an integer times a fraction. Remember, you can divide by the denominator, multiply by the numerator, and you can do that in either order. I'm going to go ahead and divide first. 18 divided by 3 is 6. 6 times 5 is 30. So that leaves me with 30 on the right side of my equation. Comparing these two equations, the one on the right is much, much easier to deal with than the one on the left. Inverse operations, to get rid of the subtracting by 4, I'm going to add 4 to each side. That leaves me with 2x equaling 34. Divide both sides by 2 to get rid of multiplication by 2. And we still end up with the same x equaling 17. Only difference is I didn't have to pull out a calculator to figure things out on the equation on the right. On the left, I had to kind of think about it a little bit more. Not impossible, but quite a bit easier to do this stuff on the right. Video and try this one. Did you get x equals 9.5? If you did, give yourself a swirly dotted line.
Here are your 3 homework problems tonight. Make sure to show your work, and to guarantee that you've done it correctly, I recommend checking your answers. See you tomorrow.